Welcome back. Now this is an example for fast retransmission. Fast retransmission occurs whenever the receiver understands that the data is not received properly at the other end, and it receives 3 continuously acknowledgement for the previous data sent. So we'll try to understand that scenario. So the client has initiated a segment or the transmission of the segment from 101 to 200 to the server. Now this is received by the server, and there are 2 segments that has been sent continuously, 101 to 200 and then 201 to 300. So the server initiates an acknowledgement saying that the next expected segment is should start from 301. So it will receive by the client and it will stop the timer. The RTO is immediately started when the sequence is initiated, for the first sequence is initiated, and once it receives the acknowledgement for the data till now whatever it is sent, it will stop the timer, and then again when the next data is sent, again the timer will be initiated. So when the next data is sent, that is from 301 to 400, it is shown that somewhere it is lost, and after that 401 to 500 again it is sent. So because 301 is not received by the server, so it will again acknowledge 301 for the client. It will say that the client must send again 301. So this will be taken as the first duplicate. So this is the original plus first duplicate acknowledgement that has been received by the client. Again the client will send 501 to 600 data that it wanted to send again. So it will be received by the server, but try to see that because 301 is not received, so that is kept as empty. 400 is received, after 400 500 is received, 501 is received, up to 500 is received, then 501 is received. So once the 501 is sent, it will be stored there. So there will be a gap of 301 to 400, so it will still wait for that, and then again it will send the further acknowledgement. So this will be acting like a second duplicate, and then again the client will send the next sequence, that is from 601 to 700, because the timer is not over yet. So it will again send this thing to the server. The server again sends an acknowledgement of 301. So now we can see that there is one original plus 1, 2 and 3 duplicate acknowledgement received by the client. So immediately the client understands that 301 to 400 data is not been received by the server. So immediately after that it will stop the process, and it will again reinitiate the sequence number 301 to 400, which is supposed to be lost somewhere. So it will send it again, and once it receives this, so it will not send the acknowledgement for rest of the things. It will send the acknowledgement for the last segment or end of the segment that is received. So once because 700 is received properly by the server, so immediately it initiates 701. So acknowledgement of 700 is given as 701, and once client receives 701, it understands that rest of all the segments from 400 to 700 is received properly by the server. Then there is one more scenario where the loss of acknowledgement can be seen. Suppose if first sequence is sent, the RTO is started, and the first sequence sent from 501 to 600 to the server from the client side, and again 601 to 700 is sent from the client to the server, and because these 2 are received, so the server will initiate an acknowledgement for 700, keeping it as 701, because the next segment that is expected should start with 701. But on the way, if it is lost, if somewhere it is lost, then the client, because the time is not yet over, the client will again send the next sequence number from 701 to 800, and it is received by the server. From 801 to 900, it is received by the server. Suppose if after 900 again the server sends 901 to the client, so the client will understand that till 901 all the data is received properly by the server, because though there is a loss of acknowledgement in between, the client has nothing to do with this acknowledgement, because 901 is received. which says that up to 900 everything is received properly, and now send the 901 number of sequence by the client. So after that the timer will stop, and once this is received by this, again a new segment may be sent with the timer again initiated from 0. This is the lost segment, that is the lost acknowledgement corrected by resending a segment. So what is happening here is that suppose 501 to 600 is sent, and then 601 to 700 is sent. At the same time, at the start itself, the RTO timing is started. So after that, suppose if 701 acknowledgement is sent and somewhere it is lost. So because it is lost, and if the same sequence is sent after waiting for some time, if the same sequence from 501 to 600 is sent, then because here we are restarting it. Why we are restarting it? Because the time is over. If the time is over and the acknowledgement is not received by the client, it understands that this segment is not received by the server properly. So immediately it reinitiates 501 to 600 sequence from client side to the server side. Now because the server has received this also in a proper way, so it understands that this is a duplicate data, because this is also received, this is also received, and this is again resent, but which was already properly received. So it will discard this sequence from 501 to 600 and again initiates a acknowledgement of 701, because up to 700 server has received. So if it initiates the 701, then the client understands that 501 to 600 and 601 to 700, both the sequence numbers are received by the server. Now in this case a deadlock can occur. When this deadlock will occur, we know that there is a receiver window set by the receiver side, and according to the receiver window the sender window is set. Suppose if the receiver window is full and it sends an acknowledgement with receiver window size as 0. So if the receiver window size is 0, then the sender cannot send any data. So the sender also makes its own sender window as 0. But suppose if sender stops, because the sender's window size is also 0, receiver's window size is also 0. Suppose after some time the window for the receiver is open, and we get a non-zero value. For example, if 10 bytes of data can be received by the receiver, because the receiver window is of now 10 bytes, and the acknowledgement is sent to the transmitter saying that now the receiver window is having a number of 10 bytes, or it is a non-zero value. Suppose if that particular acknowledgement is lost somewhere in between, then the sender will never come to know that the receiver window is initiated again with the non-zero number. Then this sender will keep on waiting for the acknowledgement from the receiver side for the RWND, that is receiver window with the non-zero number, and sender will not send any of the data to the receiver. Receiver will wait for the sender to send the data, and sender will wait for the receiving window size to be sent by the receiver. So in this case there cannot be any communication, hence this is called as deadlock. Thank you very much. We'll try to continue in the next session.